Okay, now I'm going to kind of quickly run through at least several steps, maybe the whole thing, calculating all these quantities using delta t equals 0.02 seconds without writing out all the details. Remember, we've already reasoned out what the rate of change of omega with respect to t means, what the rate of change of theta with respect to t means. So we know what alpha means, and we know what omega means, and we know how to calculate these things as we've seen over here. So if t is 0, theta is 1.2, omega is -1, what's our delta theta going to be? Well, it's going to be omega times delta t. -0.1 times 0.02 is -0.002. Alpha, we're going to take theta and plug in to the definition. We're going to get about -120. So the delta omega is alpha times delta t. 0.02 times -120 is -2.4. So our new omega is -2.5, -2.4 added to the -0.1, and our theta is 1.2 and -0.002, that's 1.198. So now t is 0.02 seconds. Theta is 1.198, not much change there. Omega is -2.5, now that's a pretty good size change. And delta theta is negative, well, then we have to calculate. Delta theta, multiply omega by delta t. And this is not a rote process. Again, you want to keep thinking about why you're doing what you're doing, but this is the way it goes. So -2.5 times 0.02 is -0.05, yeah. And alpha is still about -120 because theta hasn't changed very much. So delta omega is still about -2.4. So now we have omega -5, and theta has changed by -0.05. It's going to be 1.148. Now that's a more significant change than what we've seen before. Okay, so now t is 0.04. Theta is 1.148. Omega is -5. Okay, so multiplying omega, our rate of change of theta with respect to t, by delta t, we get our delta theta. -5 times 0.02 is -0.1, so theta is changing some. Alpha is still pretty much just -120. You can use a calculator and see exactly what these numbers would be. This is only, doing these things in my head. So it's still about -2.4. So that omega now, if we add that to the change in omega, gives us about -7.4. Yeah. And adding our delta theta, which is now -0.1, we've actually managed to change theta by at least an amount that we can kind of work with. Okay, so now t changes by 0.02, so t is 0.06. We got 1.048. We have then omega is -7.4. So the delta theta, omega times delta t, is going to be about -0.15 approximately, 148. So I'm being a little careless with some, not careless, just accepting a little approximation with these things. Now let's see. Now we're at less than a rate, or pretty much around 60 degrees. That's very close to 60 degrees. The cosine of 60 degrees is about 0.87, and 0.87 times 300 is, no, the cosine is about 0.5, I'm sorry. So I'm going to jump this up a little bit. Now it's actually changed in here somewhere. It's around 150 now, -150. so that our delta omega is now going to start increasing a little bit because our alpha, and our alpha really would have increased a little bit here. As I say, you can put these numbers in and see how they change. Our delta omega is going to be then negative 150 times 0.02, which is going to be about negative 3. So we're going to have about negative 10.4. We're speeding up, and our thetas are changing by more and more. We change by 0.15, we're going to be at about 0.9 radians, okay? And now our time is up to 0.08 seconds, and we're at position 0.9 radians. Again, I'm doing these in my head, approximating them, and not being all that careful. You can do the same process with your calculator, or you can figure out how to use Excel to do this. And you can also get a free spreadsheet you can download on the internet. Anyhow, omega is negative 10.4. Now that is going to give us a delta theta of about negative 0.21. Okay? Angle is 0.9 radians, which is going to bring this up to about maybe 0.6. I'm going to say maybe a negative 180 here, okay? And our delta omega then, multiply this by 0.02 seconds, we're going to get negative 3.6. And now we're moving at negative 14 radians per second. And we're at, well, we add the negative 0.21 to the 0.9, and we get something pretty close to 0.7, the 0.69, but I'm being kind of careless here. Okay, and then we continue. Now I want to check my time here. We're not doing that badly. Okay, so we bring our omega and our theta. We get 0.7. Excuse me, our omega is negative 14. So now our delta theta, we multiply our omega by 0.02 seconds. We get negative 0.28. And we plug in 0.7 radians, which is going to bring things up to about 0.7. So we're going to get about, I'm going to say negative 210 for alpha. We multiply that by 0.02 and we get negative 4.2. Here we have, okay, negative 14. Our omega, sorry, our new omega will be this omega plus the change. That's going to be about negative 18.2. Add negative 0.28 to 0.7, we get 0.42. Okay? Well, see, things are moving along. Now, moving at an increment of 0.001 over here, it's going to take a long time to get to that. But see, already we're down here. Okay, so now we're at 0.12 seconds. We bring these results over here. We get 0.42 for the angle theta, negative 18.2, there's a decimal in there. It was there, but it was kind of hiding. Negative 18.2. Multiply that by our 0.02 seconds, and we get about negative 0.36, rounding to the nearest hundredth radians. And that's going to be at 20 degrees or so, so we're getting into the 0.9 range. And this is going to make a big jump to maybe negative 260, I'll say. If you plug this angle in, sorry, if you plug, no, okay, never mind, I'm looking at the wrong thing, I was looking at this. 0.42. Okay, that's going to be about 20, 30 degrees. You're going to be about 0.87. So that's what I said. It's about negative 260. I was just looking at the wrong number. And then our delta omega is what? We're going to change. We got negative 18.2. And I'm looking at the wrong thing again. We multiply our rate of change, our alpha, by our 0.02 seconds. We get negative 5.2, giving us negative 23.4 radians per second. That's our omega. And then we add our change in theta, which is negative 0.36, to our 0.42. We get negative 0.06. So at 0.14 seconds, it's pretty clear we're going to cross 0 and our domino will be flat by this time. Now we can put those numbers in. We have what, 0.06, negative 23.4. Our delta theta will therefore be about negative 0.47. 0.02 times this. And this is going to be pretty close to negative 300. I'll say negative 290. Okay, well, okay, 0.06 radians. That's going to be really close. I'm going to say negative 297. I don't have a lot of confidence in that. I don't want to do the Pythagorean identity right now. Actually, yeah, no, 2985, something like that. So I'll say 298, maybe even 299. Okay, I did that in my head, but very approximately. Okay, then we add our delta omega. Now we calculate our delta omega. It's going to be about negative 6, giving us negative 29. Yeah, okay, we'll say about negative 29. And this will be now negative. So we're done. Got to check my time again. We're still okay. Okay, so that took about 11 minutes. And I think most of these numbers are mostly right. The trends are okay. My mental arithmetic could be a little suspect, so check me out. The point is that in 0.14 seconds, according to this approximation, this 0.02 second approximation, this is what we get. Okay? Now you can feasibly do that by hand. Now it took me 10 minutes doing it sloppily in my head. If you're punching things into a calculator and not taking shortcuts, it'll probably take you half hour. If you use Excel, get the first couple of steps set up, drag it down, it takes you just a couple of minutes. And if you know how to program, it's it'll be a really pretty simple thing to program. You probably program this if you're any good in 5 minutes and get your answer almost instantly. So, what's this telling us? Well, here's our omega. We see that we're speeding up. These numbers get bigger and bigger. And by the end, we're moving at like negative 29 radians per second. Now, about 6 radians in a circle, so that's about 5 times around a circle in a second. If the domino kept moving at the speed it is when it hits here, it would go through about 5 revolutions in a second, about that fast. Okay. Well, there are many other things you can see in this, but we'll let it stand at that. Oh yeah, the other thing is, and I want to take a good close look at this, is that 13 minutes or 14? I think that's 13. I've got a few seconds. Okay. This is actually shorter than it will actually be, and it's because, I'm going to back off on that. I'll let you think about whether this is shorter or longer than the actual time would be if we had a shorter time increment. Okay, that's a more subtle point. I want you to think it through. I was about to say something quickly. It's late in the day, I'm getting hungry, and I decided I didn't want to say it without thinking it through.